Hello, I'm Rebecca the Maths Lady and welcome to this video which is all about teaching area. In this video I'm going to cover how we teach children so they have a really deep understanding of what area is, which is often lost. And then we'll talk about the different units that are used for area, and we'll talk about how to teach children to find areas of rectangles, triangles, parallelograms, rectilinear shapes and irregular shapes. The assumptions for this video are pretty basic, that children have come across the shapes we're going to cover in their work on two-dimensional shapes and that they've done some measuring of length. I think we can pretty much take that for granted, so let's get started. Introducing the idea of area is best done with an example like this. Here are a couple of rectangles. Which is bigger? Now, if children have never come across area before, they're used to focusing on a single dimension. So the first thing that will strike them is that this one is bigger because it's longer, but that's contradicted by this one being bigger because it's wider or taller, depending on which way you're seeing it and which vocabulary you're used to using. So I would set children to talk in their groups, try and puzzle out which is bigger. We could relate this to a real life example. If you were tiling a wall, which wall is bigger? And that can lead to the insight, which one do I need more tiles for? And prompt children to look at the squares. So this has an area of 10 squares and this has an area of 12 squares. Therefore, this is the bigger rectangle, but this one is longer and this one is wider. So length, width and area are different things. An area is about the space that a shape covers. And we usually count area in squares. We could count it in triangles or hexagons or any shape that tessellates and covers space with no gaps. But squares are so much easier to see. And the squares we use are usually centimetre squares or metre squares, or for very large areas, kilometre squares. But it's nice to talk about some other measures of area like acres or square inches or anything like that that children might come across in real life and draw their attention to the fact that they do all calculate area. When you come back to area the next day in a new lesson, it's worth giving children a ruler and saying, please can you measure the area of this rectangle? And hopefully they'll say, but I can't do it with a ruler. And then you can start trying to fill the area of the rectangle with the line that's the edge of the ruler and draw that contradiction between one dimension that, unless the pen has a decent width, will never fill flat space. You can't calculate the size of that space with lines. In practice you kind of can, but that's engineering, not maths. In maths you can't, because lines have length but no width. Big ideas, and children like big ideas. So let's just talk a little bit about the units that children are likely to come across. So the first one is the square centimetre, which is usually written as the unit with a superscripted 2 for square, and we can draw their attention back to that square being about squares. Remember square numbers? We did a whole video on that. I'll just post a link to it. But in essence they want to remember that 6 squared was 6 lots of 6, and we built it with Dean's blocks or paper squares, and 6 squared is the area of a square that has side 6, and a centimetre squared is the area of a square that has side 1 centimetre. Now there's lots of ways that this is said. It might be said as centimetres squared, square centimetres, centimetre squares, and so on. And children need to become familiar with all of those. But most of all, you need to draw attention to this superscripted 2 as being to do with squares, not to do with multiplying by 2. And then, of course, we have square metres and square kilometres. And we could also have other square units. Let's look now at areas of rectangles. Well, the great news is that if you've watched any of my videos on multiplication, right from the foundations of multiplication through tables, through mental multiplication, through long multiplication, through multiplication of fractions, children have always been doing those multiplications by finding the areas of rectangles, because that's what array is. And we have usually used centimetre squared paper. This is an array pack for the 6 times table. So 10 times 6 is 60 square centimetres. Here's a worksheet from multiplication, 19 times 12. Children have already been puzzling out how many square centimetres that is. Array and area are similar words, and they are really similar ideas. So it should come easily to children that to find the area of a rectangle, you multiply the length by the width, because it's that many rows of that many squares, or the other way round, depending on how you look at it. So of course children need practice so they get used to using their notation and seeing the types of problems they'll come across. But if they've learnt multiplication with array, they should be able to work on really complicated questions that involve numbers that aren't whole numbers or large numbers very quickly, because they've already done that maths. The next shape that children usually look at is triangles. The simplest triangle is a right angle triangle, one like this. And children need to know that the area of this triangle is the base times the height and half it, because it's half the area of this rectangle. And it's great if they can actually cut out rectangles and cut them in half and know that for sure. If they just learn that the area of a triangle is base times height and half it, they will forget. And they won't know how to be sure if they've half forgotten or completely forgotten. They can't rebuild that knowledge. If they've been through this quite a few times until they're absolutely sure of it, and they've been asked to justify it to each other and asked to explain how to find the area of a triangle to you, there's much more chance that they'll remember it. Let's look at a slightly harder triangle now. Maybe one like this. Now this, it isn't as easy to see that it's half the area of a rectangle, because where's the rectangle? Well, we can draw a rectangle like this, and if this is a perfect rectangle, sorry I've drawn it freehand, then this triangle is half the area of the rectangle, and you can see that most clearly if you drop a line here, and then it's possible to see that this part of the triangle is half the area of this, and this is half the area of this. Therefore we've got half the total area. And again, it's great to actually cut triangles out and get children to make displays of this proof so that they're absolutely sure in a multisensorial way and they've time to digest it and think about it. And you can go and talk to them and check that they understand. But there is an even harder type of triangle, and that's this type, the leaning over triangle. Of course, you could do it this way up, but maybe you don't have that base and that height value given, so we need to go back and look at it this way. And if you're given the base, if you say that's 5 centimetres, and you're given the height, say that's 6 centimetres, then following the rule, the area of that triangle is half the base times the height, so that'll be 15 centimetres squared. But how? How can you see it? Well, the key here is to extend a rectangle. So if we say that's 4 centimetres, then I'm sure we'd all agree that the area of the rectangle is 9 times 6 is 54 square centimetres. And the area of this triangle is half of 4 centimetres times 6 centimetres, which is 12 square centimetres. And the area of this triangle here is half of 9 times 6, which is 27 square centimetres. So if we take the total and subtract the other two triangles, it'll give you this one, and it does always work out that this one turns out to be half the base times the height, working through that method. Now, the general rationale for this requires a bit of algebra that's beyond this level, but children may be able to express it in words, and it'd be wonderful if they could. The next shape we look at is the parallelogram. And here the key insight is that you can cut the leaning over bit off as a right angle triangle and move it and stick it here, and then you get a rectangle. So the area of the parallelogram must be the base times the vertical height, because that's the area of the rectangle and they are the same. So again, it's great if every child can make one of these, every child can cut one, be absolutely sure that it's true. You might want to set an exercise with some parallelograms on squared paper, get them to reason, get them to puzzle them out, get them to count the squares. But the key thing is that you as a teacher know exactly what understanding you're looking for from the child, and you can talk to them and you can quickly puzzle out if they deeply get it or not. So you can zone in and work with the children who are struggling. And as ever, their peers might be able to help them. It's very powerful learning if children learn from each other. Now, children are also expected to be able to puzzle out the areas of rectilinear shapes. Rectilinear shapes are just shapes that are made up of rectangles like these, and you could let children find the areas of these by counting the squares one at a time, and some of them might like to do that, but it's a lot quicker if you start to split them up and reason. That's 6 high and 9 wide, therefore the area of that is 54 square centimetres, and this is 3, 6, 10 high and 5 wide, so that's 50 square centimetres, therefore the total area is 104 square centimetres. And of course you can do something similar with this. At some stage I'll try and make some worksheets and post them in the usual places, just so they're there and handy for you to download for free. Right, there's one more key component of this topic, and that's finding approximate areas of irregular shapes. So a classic one to do is your hand. Here I've just drawn round my hand, and children could start counting off the whole squares one at a time and labelling them with numbers as they count them off, but that would take a long time. It's easier to think in complete rectangles. So we've got 2 centimetres squared there, and then we can carry on. So I've sectioned off all the rectangles that I can get out of that and added up the areas of the rectangles. That's got me to 113 centimetres square so far. But that leaves me with all of the part squares, and I have to start to reason as to how I will put them together to make whole squares that I can count. So if we just look at these top 2, I might decide that that approximately fills this square, so therefore this will be 1. And I'm just going to count with numbers just now. And then I can put together maybe that and this one. So there, that'll take me to 2. That maybe needs this and 3, or children will start to put together different bits of squares from different parts of the hand. That's okay. But they want to carry on composing full squares until they've covered the whole hand and have an answer. It's quite powerful to give children all the same worksheet rather than having them all doing different hands, because then they can fight about who's got the most accurate answer and why. And if someone's gone wildly wrong, it's going to be obvious. Now, this is a really important task because it drives a deep understanding of what area is, and it also is a powerhouse for developing understanding and reasoning about fractions and putting fractions together to make wholes in a pretty unique way. And it's really important to get children talking about their strategies for composing whole squares, because when they do that, they're articulating their thinking, and when they articulate their thinking, they come to understand their own thinking more deeply. Right, there's one really powerful task on area that I want to show you at this stage before we look at wider topics that are also important for teaching area. And that's a task where you start with a simple shape. Let's say it's a 5 by 3 centimetre rectangle. And we draw a noughts and crosses grid here. And we're going to label one direction perimeter and the other area. It doesn't really matter which is which. And what we're going to do is ask children to find shapes that fit in each part of the grid if this is your starter shape. So can you find a shape that has the same area, the middle column and row are the same, but a bigger perimeter? Can you do that? Squared paper might be useful. It's certainly a useful tool to have around. Can they find a shape that has the same perimeter but a smaller area? The easiest ones are the shapes with smaller perimeter and smaller area and larger perimeter and larger area. They should come very quickly. Are there any parts of the grid they can't fill? Are there any parts of the grid it's not possible to fill? Can they find more than one shape in different parts of the grids? If so, can they describe the sets of shapes that fit in different parts of the grid? This can go on all day and it's really powerful work. You can make beautiful display out of it, either as an individual, in pairs or in groups. And groups that work on this can compare and contrast their work and their answers. So if you're having a stressful time, just lean into this task, let it run all day, let your class calm down. So where else are we going to come across area? We might be able to use it in art, craft and design projects. We come across it when we consider paint coverage. It's there on tins, what area of wall each pot of paint will cover. Could your children find the area of the school field? We're going to look at this in more detail in the next video, which is on 3D shapes, but we're also going to look at nets of 3D shapes and surface areas of 3D shapes. So plenty of area in that. We'll also come back to area in the video after that, which is about volume, and we'll be contrasting length, area and volume and talking about how we teach children to have a razor sharp understanding of the similarities and contrasts between the different types of measurement. So in this video, we've talked about how we get children to have a deep understanding of what area is and the kinds of units we use to measure it and how they're notated. We've talked about areas of rectangles, triangles, parallelograms, rectilinear shapes and irregular shapes. And we've talked about that challenging area and perimeter exercise with the noughts and crosses grid and some of the other areas of maths and wider life where we may come across area. I hope you've enjoyed the video. Don't forget to use these applied topics when your class are tired and stressed and everyone's fracturity. It's such a lovely change of pace to do something really practical away from your number work. It reintegrates the class. You can start with everyone working at the same level again. And it's much easier to let lessons run all day and just take the stress out of what everyone is doing when you're working on an applied topic. If you found this video useful, if you could share this channel with your friends or anyone else you think might find it useful, or in social media groups, that would be fantastic. Thank you so much for the time you're spending working on being a fantastic maths teacher and for helping us to create a generation of children who are all superb at maths. This world needs it. If you want to see the full list of videos that I've got available, you can find those at www.authenticmaths.co.uk/videos. Hope to see you again soon. Take care. Bye for now.